Good morning, everybody. We're going to get started. Good morning. I'd like to introduce myself. My name is Tom Vaya. I'm the chair of the Long Point Biosphere Region, and I've been in the role now for 5 years and on the board for 5.5. So it's been a pleasure to be a part of this group, and I'm seeing many familiar faces now, given that this is our 13th Long Point Biosphere Research and Conservation Conference. So tremendous longevity, and I think what you're going to hear today is amazing, as it always is. We'll open the meeting with a land acknowledgement. We acknowledge that we are living, working, playing, and stewarding on the traditional treaty lands of the Mississaugas of the First Nations. In particular, we would like to acknowledge the Neutral, the Anishinaabe, and the Haudenosaunee peoples. We are grateful for all the generations of people who have taken care of this land for time immemorial. So the meeting is officially open. So I'd like to, again, welcome you. It's amazing that we can come together and celebrate conservation and biodiversity. As many or most of you know, Norfolk County is one of the premier regions in all of Canada for our biodiversity. And all of you are here because you care about that. And the board of the Long Point Biosphere Reserve also cares very deeply about that. And even in the room, we've got many people that have been involved with the board over the years. We've been a biosphere since 1984. So my time and our time is just a point in time on this incredible journey that we're on here in this region in looking after the biodiversity and the conservation works that we do, so that we can leave these lands in this incredible biodiversity in place for generations to come. So thank you for your interest. Thank you for your participation. For those that work with us on committees and boards and volunteers, and many of you do all of that as well, this is always a time for us to say thank you for that direct work that you do. We'd also like to thank Norfolk County. Norfolk County has been very involved with us this year. More involved than in recent years. We formed an MOU in certain areas to be, and I think you'll hear a bit more about that later this morning, in some of our areas of road ecology. And so the biosphere and local government is also coming closer together and taking action to work towards the preservation of our amazing biodiversity in this area. There's also been tremendous collaboration and movement and collaboration this year amongst the various conservation authorities that operate in Norfolk County as well. And we're very proud of some of the changes that we've made and some of the affiliations that have strengthened. And I'm going to say strengthened under the leadership of Janet Dassinger. You'll hear Janet today. In fact, I'm going to bring Janet up in a moment. Janet was appointed as our interim executive director about a year ago. And Janet's a Long Pointer. She served on our board. And we had the opportunity for the first time, I believe the first time in the biosphere's history, to actually appoint a paid executive director, paid through grants. And Janet embraced it. She has done more work than I've ever seen someone do leading an organization. And one of the many, many things that she's accomplished this year has been to reach out to all the other leads in the various groups that are working on conservation and biodiversity in the area and bring us together. And there's tremendous vision moving forward with Janet's inspiring others to come together so that we're all actually working together rather than working independently. So let's give Janet Dassinger a round of applause. I think, Janet, you've done an amazing job. So thank you for being here. Janet, I'm going to bring you up. I believe you're moderating the first session, and I'll be around all day if you'd like to talk to me about the biosphere or any other ideas you may have. I'll be here for breaks and lunch, and just stop by. And you can also find me if we don't get together today. My contact information is on the website. You can find me through the website, and you can call me or email me or whatever you like. But I always love to talk about the biosphere, and I love to talk about Norfolk County, and I love to talk about conservation. So thanks very much, and have an amazing day. Janet.
Grab that mic. I can hold it though.
Okay, you can put it on the desk.
Good morning, everyone. Thank you, Tom, for those very, very kind words. I'm blushing. I'm going to introduce our first session, and this is a real pleasure for me because everyone who is presenting is a contractor with the Long Point Biosphere region. And I have the privilege and the great fun of working on a daily basis with all of these very strong individuals. So I just want to make my debt of gratitude to them, because without their untiring work and dedication, we would not be able to execute on the deliverables in our contracts or to build the biosphere. And we are a very strong team, and I want to thank them very much. So our first presentation is Carrie Gunson. Carrie founded EcoCare International in 2009. That's a company devoted to implementing applied road ecology solutions across North America. Her primary activities in that capacity are planning, designing, implementing, and monitoring road ecology projects at a municipal and provincial level throughout Canada. Based in Southern Ontario, much of her work focuses on lessening the negative road impacts for at-risk amphibians and reptiles that occur in Norfolk County. As I'm sure everyone knows, we've had very high mortality rates for species at risk, and much work done in that field over the years. Some of her milestone achievements include monitoring Canada's first iconic wildlife overpasses in Banff National Park, and leading the development of a Wildlife on Roads handbook and participating in the development of the Biosphere Wildlife Road Watch and Turtle Hatchery program. Carrie works very hard and is our road ecology expert, along with Lauren Nightingale. Lauren is the road ecology program coordinator for Wildlife Road Watch and the Turtle Hatchery. She began working as a road ecology technician under Carrie in 2022 after volunteering for the Wildlife Road Watch in its pilot year. Lauren graduated from the University of Guelph with her second science degree in animal biology, and has since dedicated her career to saving the most vulnerable members of our community. We always have her various fosters joining our staff calls. She is our turtle whisperer, and very thrilled to have both of them present to you today. So, Carrie?
Okay, so Janet already went over. I started in Banff with larger animals and road ecology, and then came to New York State and Ontario, and I've been working with reptiles mostly, but also I will go over some of the work up north on Highway 69 with pretty much a diversity of large and small animals. So we heard about reptiles and road impacts. Well, we have a lot of species at risk. A lot of them are in Norfolk County, reptiles, and it is the most endangered taxa in the world and in Canada. Some of the threats. Thank you. We know road mortality, we see it, it's obvious. Fragmentation from the roads when the animals can't cross, and if they do cross, they get killed. So that's isolation and fragmentation in their habitats. If those habitats are no longer viable for those populations, then we can lose entire populations just because they're surrounded by roads and other development. Predation is so huge in some places more than others, where there's more people, more tourists, more subsidized predators, such as raccoons at Subic viewing area near Eco Adventures. The predators wait in the bush and come right out while they're nesting, and this one's scooping up this snapping turtle's eggs as the snapping turtle just laid them and is leaving to go back to the marsh. And also they can't find enough nesting habitat anymore in the marsh. So they come up to the roads and they nest on road shoulders. So that's obviously a dangerous situation. The turtle's now exposed and to vehicles, people, predators, etc. Yesterday with the fox snake, and the fox snake, 70% of its global range is here in Ontario, mostly Ojibwe and Norfolk and up by Georgian Bay. 3 components for road ecology are crossings for connectivity. I mentioned the fragmentation. We need to get them from A to B across those roads, so we install tunnels or overpasses. And directional fencing is key to span their habitat and funnel them to those crossings when we put them in. Sometimes you don't need them if the crossings are a natural bridge area drainage where they're crossing anyway, but most of the time you need a little bit of wing wall or exclusion fencing to lead them there. And creating habitat is huge, and we are working on doing that for turtles with nesting habitat. You'll hear more about that at my case studies. Designated wildlife crossing structures would look something like this. They're typically dry. These ones are dry, but you can also have designated ones in the wet, but most often in the wet environment, you will have a culvert or a bridge already. So you can modify that structure to work for your target animals. So we're going to go through 4 case studies very quickly, spanning adjacent to our Great Lakes. That's where a lot of these animals occur. Hello, hello? Better? These 3 of these case studies were quickly summarized in Ontario Nature, the summer 2025 Earthwatch article. So you can find some information there, but also you can find information from me. Highway 69 was monitored for reptiles for 10 years for reptile crossings, and it's probably the largest database at a diversity of crossings for reptiles in the world that I know of. They had 1 overpass and several larger underpasses, 3.2 meters by 2.8 meters, quite large. So we monitored a diversity of those box wet type culverts. Monitoring turtles is not easy. There's not a lot of them, like deer, for example. And also they're cold-blooded, so the cameras don't necessarily pick them up. So we do time lapse. So what we found, I'm just going to go back to that slide, was that openness, light is always a key attribute that we want in our crossings. But in this study, when we compared, we had the same sampling effort at 2 structures of same size, but one was not open in the median and the other was. We found more crossings at the closed median, less light, but that was because of location. The location of that crossing was where there was beavers and turtles and a lot of abundance of turtles adjacent to the structures. So the location is hugely important, just as structure is. This is our database, over 8 years of monitoring, and 16 blandings because they're more rare. So that's the blandings going through one of the culverts. I mentioned this already with the hydrology impacting the abundance of animals using the structure. We found that painted turtles cross the structure most often, followed by, snapping turtles, followed by painted turtles, and then blandings. Well, actually, they're all blandings and painted were pretty much equal. So they are crossing instead of turning around. Another thing we looked at there was the difference between snakes crossing and turtles crossing, and we found that turtles crossed more often and snakes turned around. So they may be more sensitive to temperature fluctuations in those crossings. So now we're going to move to Port Frank's Pinery Provincial Park, if you know that area. And there was a situation where there was a lot of turtles crossing for, we think, for nesting habitat, and the road bisected, Cottage Road bisected provincially significant wetland. So we put HDPE and we attached it to a guide rail and we funneled the turtles. It was a short section, about 200 meters, funneled the turtles to an existing large wet culvert that was 75% submerged with water. Some people didn't think turtles would use submerged culverts because not enough light got in, or they couldn't get air if it was submerged, but we found quite the opposite. We found 5 different species of freshwater turtles use that one culvert in 2 monitoring seasons with time lapse. And I have the numbers, but it was about 200, just over 200 turtles using that crossing and verified crossings. Now we're going to go to Kingston, Ontario, where we had a complex site because we had development, a residential development at the northwest quadrant of the site. 2 roads were a newly built road for the development, and then an existing road, Princess Street, with so much traffic, which was the old 401. And so we had existing structures that we could use, and we added a structure, we upsized the structure, and then we built 12 nesting mounds. And we also put a fence around one of the wetland quadrants where the development was. You can see the orange line there, and that hadn't really been done before. And so there was a lot to learn from this site, so we did monitor, and there was predation going on as well. So this was on the north-south road that they built for the development. They upsized the drainage culvert, plus they put in a dry open-top ACO tunnel, which is on the left, which we have here on the causeway. And we found that turtles use more the drainage culvert, which didn't have as much light, but not because it was darker and they preferred that, but it was location. It was at the drainage where they were going back and forth anyway, and they maybe just didn't know about the dry tunnel further north. But the dry tunnel is important because that was leading to the nesting habitat on the east side. This is an example of a comparison of a drainage culvert with an open-top ACO tunnel closer to here. This was Roseville Road and monitored by NRSI. And they found that there was more turtles using the open-top lighted tunnel when there was this smaller drainage culvert adjacent. So in that situation, we know that they prefer the open-top tunnels. So those are the kind of things that are important for us to look at to inform crossing structure design. The nesting mounds. Nesting mounds is somewhat of a new science, especially up north in Georgian Bay, where Dr. Marco's working with landing turtles' nests. Down here in southern Ontario, we tend to put fill in and mimic road shoulders. So we get the granular A substrate. And we know snapping turtles use that granular A very effectively, but we don't know necessarily what painted turtles use. So that's what we need research on, because you'll see an example of painted turtles not using the habitat. And they did not use the 12 constructed mounds, even though we know they're abundant. It's provincially significant wetland. So we were looking for snapping turtle nests because that's what we're using our mounds. And we knew there was approximately 100 snapping turtles nesting in this Princess Street area at this site every year. And we verified that with the nests. So this is an example of how we constructed the nest. The contractor took out all the veg, then added riverstone rock, because it was right in the wetland. So they had to be high up. A lot of riverstone rock, pea gravel on top, and a pea gravel sand mix on top. Pea gravel, sand, and gravel. Sand, yeah, I got it. So they're sloped, and the turtles just came right out of the wetland and used them right away. They didn't really have a choice. The first year they were somewhat skittish. They probably are skittish just when they nested on the road as well. And again, we didn't see any painted turtles. Some nested along the exclusion fence. What we found the first year was a rogue skunk was digging under our nest box cages and getting at the eggs. That skunk, we think maybe was roadkill. We found it roadkill later. And we since haven't had a rogue skunk since. But the raccoons have taken over. So we've somewhat created a feeding station for the raccoons. The first year, the raccoons didn't find these mounds, but the second year they did, and this year they certainly did. So we tested some different box cage designs to deter that digging under to the egg under the cages, because the substrate was soft after it rained, and we found that it was effective if we put a skirt around the nest box. So that's one thing you can do for our nest boxes. I don't want to go because of time, but there's way more to that study. We found that the hatchlings successfully emerged from the substrate, so we know the substrate was able to incubate them at a proper temperature with drainage. And what was great about those nesting mounds, they were really close to the water, so the hatchlings could literally roll down the slope right into water, except for this year because it was dry. But we figure they probably hunkered down in the vegetation, and then with the rains in September, they were hopefully able to move to where they could hibernate. We found the fencing very effective for no turtle mortality, except that we've had a few ones squeeze through some gaps. Maintenance is important. And the connectivity achieved with the crossings. We weren't able to monitor the bridge or the box culvert because they were submerged with water, but we know that they're going through those because they're big structures. Okay, so that brings me to here. How much time do I have? About 5 minutes? Okay, perfect. So that brings me to what we're doing here with the priority place, and Lauren's going to talk about the programs that Janet mentioned that she's running, and I'm talking more about the mitigation that we're doing and would like to do more of. And Tom mentioned that we're collaborating with the county and other partners too. The other partners around Land Trust, MNRF, and MECP, hugely important for getting this mitigation in. A lot of collaborative work. So I think we can go here. So at Eco Adventures, Turkey Point Marsh, the turtles come up, but it's a situation where the hatchlings can't necessarily get back. And you're going to hear more about that later today as well. So what we did was we mimicked somewhat Kingston, but we didn't need connectivity at this site at Eco. It's the third field right between Burning Kiln and Eco. We didn't need connectivity because the wetland, the marsh, was south of the road, and north of the road there was a pond, but they have the marsh and another pond at Eco property. So it was nesting. We didn't want them to nest on Front Road anymore because crossings, vehicles, roadkill. So we built nesting habitat. We did similar nesting habitat as we did in Kingston, but we didn't have to do it in the wetland. We had the prairie meadow area to put it in, and we put the exclusion fencing similar to Kingston. I show this picture of the turtle plastrons because they're all unique for the 8 species in Ontario. This shows 9 species because I think there's a red-eared slider in there. But the individuals also have a unique plastron. So if we could take a picture of the plastron of the turtles, then we know that they're coming back routinely to nest at these nesting mounds. That'd be great information for our surveys. So this was the first year of the results, not this year, but the year before. The turtles nested on the east side and the west side where we built the 2 mounds. That mound you saw was east and west, about 20 meters, 30 meters each long. And so we had more than the west side is closer to the water. So we figured that they were nesting more on the west side. Made sense? So, but then this year, I didn't have time to make similar figure. But this year we found, and Lauren can verify, but 5 nests. This shows 1, 2, 3, 4, 5 nests on the east side. And Lauren Rago is going to talk about this more as well. And none on the west side. Is that true, Lauren? So completely different, but it was a dry year, so maybe that was something that contributed to that. Or maybe they just wanted to go to the east side this year because they knew that the hatchling study that Lauren will talk about, we wanted them to nest on the east side, so they did that for us. Unfortunately this year, we did have 2 painted turtle roadkill at the fence area, whereas last year we didn't. And the painted turtles probably went around the fence, or maybe they came from the other side. We're not entirely sure. So that we want 0 roadkill, so we'll maybe extend the fence a little bit more. We did do turnarounds, so to try and bring them back. Maybe a couple jump outs, escape opportunities for them to get back over. But what we did have this year was a Blandings turtle on the east mound. And is that picture there? I think it's the next picture. So that's the Blandings turtle, and that's always a great thing that happens. And I don't think we put it there, it went there itself. 2 Blandings, and Lauren, I didn't have time to put the footage, we had a camera up. What happened here was it started nesting, and Lauren showed up a couple hours later, was able to watch over the eggs being laid and excavate the eggs for the hatchery, and she'll talk about that. And it's a good thing because as soon as Lauren left, within 5 minutes, a raccoon was right there. And we got that all in footage. So mimicking that kind of strategy across Ontario End here would be awesome, because it doesn't necessarily need those expensive crossings, or that we understand how to put fencing in. We're getting better at it. We're training people in the area, getting the contractors, we're getting our partners. So we've moved to this conceptual design at Erie Boulevard, where we want to keep the turtles on the north side of Erie and no longer go to the residential areas and crossroads to nest on the south side. And so that will be similar nesting mounds and exclusion fencing. And I wanted to end with our vision, the MOU of collaboration that we're working on right now with Norfolk County. It will be huge, so because previously we'd get funding, we have to spend it within a fiscal. Norfolk County is not aware of what we want to do, and we weren't in jiving. So now we hope to jive and have our timelines. So if they're doing a road upgrade project in one of our areas where we want to do something, then we can ask for their contribution, and we can contribute as well. And there is wildlife crossing guidelines in Guelph that is a municipal example of this type of collaboration and initiative. So these kind of things are just happening now, these collaborations. They are so important. And there's Wildlife on Roads, which is a not-for-profit I hope to incorporate, which can contribute to these kind of collaborations. And EcoCare hopefully will retire. And then we can just look for turtles and save them. So we did a passage rate. That's how we do that. It's number of crosses, verified crosses, divided by number of turnarounds plus crosses. And then you get that percent. And I think the snakes were like 70% and the turtles were like 80%. Then you do a statistical analysis. There is a paper on this. It's in French.
I'm more interested in why you think they do it.
Yes. Okay. So why do they do that kind of behavior? I did some reading, and Mike Colley in Georgian Bay had looked at temperature in the crossing structures and found that they don't like crossing when it's too cold. But that was all that was out there. Just that they're very sensitive, they only move. But that's the same with turtles too. They only move at a certain temperature in the day. So whether they've basked and their internal temperatures are okay for them to move, but they don't want to go into a dark, cold tunnel and lose that temperature, internal temperature, because then they have to get it back up. So they have to move at a certain but there'd be snake biologists here that could answer that maybe a little bit better. But we really don't know. And why are they more sensitive than turtles? But it's definitely temperature, like if I had to get, like educated guess. Yep. I haven't myself, but Lauren Rago, the hatchling study, that was radiotelemetry. She'll talk about that. Ojibwe puts passive tag readers in their fox snakes and they use that method to monitor the use of the overpass that they built there with fox snakes. So yes, it's definitely something, it's more, and there is people in Georgian Bay, it's more the universities. Laurentian University did a study with, and so did Georgian Bay Biosphere, or I think that was Mike Cawley, Kilbear Provincial Park. They did some passive. And that's to see if they cross the structures, because I mentioned the cameras don't pick them up well. Okay? The question was the incidence of roadkill and whether it's increasing or decreasing? Yes. Or do we have the data? Well, yesterday at the Fox Snake Workshop, Scott Gillingwater mentioned that he's noticed from doing his long-term monitoring in Long Point area, fewer fox snakes being found, being observed where he's seen them before. So but that's observation, not necessarily on roads. But roads would be a good, survey data would be a good tally to look at that. You have to be careful though, because are they less because they're just not on roads because we've done a good job of keeping them off roads? Or are they less because of roadkill itself? Chances are it's probably roadkill. The idea is the hatchery, which Scott will talk about, releasing turtles and saving these turtles from being killed on the road and releasing them safely in 25 years. They will replace what is being killed on roads. That's where we'd like to get.
Okay, so Janet already introduced me earlier, and I'm Laura Nightingale with project updates for 2 main road ecology programs for the biosphere. So there's Wildlife Road Watch. So it's a citizen science program where we train our volunteers to do all of this on the right side of your screen. So the focus is on helping turtles during nesting season, which is June, because as Carrie sort of talked about a lot already, turtles love to nest along roads. This one on the left side of the screen is a Blanding's turtle that was actually nesting in the middle of the road at 10 p.m. You can actually see the tire tracks. She was nesting right there, right where a car would go by. That was a first for me to see. Usually they'll stick to the road shoulders. And we did work in Long Point Park this year, and the park staff was kind enough to put up a traffic cone next to this map turtle that was right on the shoulder. Yeah, usually they'll stick to the shoulders. And then the bottom right, why can't I think left and right today? That was actually the side of a highway, and you could see that snapping turtle sticking her little head out. And if someone doesn't like turtles, they just have to swerve a little bit, and no more turtles. So we want to be there and guard her and make sure that she does not get killed by a horrible person. So here are the observations for the past 3 years of the program. It did start in 2022, but that was only like a 3-day event, so those numbers, they won't mean much. It was just like 15 turtles we found. So we now have 55 active volunteers, and we were able to help at least 369 turtles cross the road in our priority areas. I say at least because we don't always remember to take a picture. These are just our like documented observations where we've got coordinates and time and everything we need. So the AOR, that means alive on road, and then DOR, obviously, dead on road. But this was actually also the year we documented more dead than living turtles on the road. It doesn't mean that more turtles were killed, it just means that more were documented. We had more volunteers willing to get out, take a picture of a dead turtle, and then get it off the road. And that we found way more dead hatchlings than adults illustrates a point that I always like to make. A lot of our turtles and animals that we want to save on roads are very, very small. So it's not enough for drivers to change their habits. If they can't see what they're running over, they can't avoid it. I.e., we need things like exclusion fencing and nest mounts and things like that. So where we can't install fences, this is one way that we can save our turtle hatchlings. So we take eggs from really terrible places like driveways or campsites. That was in Long Point Park on the top left. The dude called me over, he saw us in our vest and was like, there's a turtle, I don't know what it's doing in my campsite, I just showed up, I want to have a fire. And I was like, you can't have a fire, buddy. You gotta wait until she leaves. So that brings us to our hatchery and exhibit. So this is where the eggs go after all the volunteers dig them up and drop them off on my kitchen counter. So here it was last year. It's right in the entryway of Long Point Eco Adventures in their new Welcome Center building. We had 2 incubators last year, and that was just a display case that I found on Facebook Marketplace for really cheap. And then the hatchery this year. Eco went like way above and beyond and built this whole custom display for us. We had banners, TVs, we had locking cabinets, we even had lights, which was really nice. And from the end of July to early September, the volunteers and I were at the hatchery every afternoon. We were candling eggs, we were measuring and weighing the hatchlings, and everything that we did was on display the whole time. So we interacted with about 2,500 guests over that time, talking to them about our at-risk reptiles. I always tried to steer the conversation to snakes, but not everyone's on board with that. But just talking about turtles as well, and just road ecology. No one's ever really heard of this thing called road ecology. So I really think this has been amazing for getting people interested. And now here are the hatchling totals by species. So the last year, which was our first year, is in white, the white bars, and this year is blue. We did actually have blandings last year. We excavated about 145 blandings eggs last year, but they all went to London, to Scott Gillingwater and his team, wherever he is. I don't even know where he is in here. He's here somewhere. He's coming. Oh, he's not here? Oh, no. Okay, well, maybe he'll watch this later. So he took our blandings last year. We had 128 blandings last year, but we really went up this year. So yeah, again, big thanks to Scott. He also took a bunch of our snappers when we went over peak. And then we got to release all of the hatchlings. So we kept them for up to 7 days, and then after those 7 days, back to the best habitat we could find within about 1 kilometer of where the nest was laid. And I had a lot of trouble finding pictures because I'm trying to convey that there's like a magic in the marsh, especially when you're out there releasing turtle hatchlings. The bugs leave you alone. It's just like all the stars align. It's magic. And then this year, we worked to bring that magic to more people with our Turtle Tours Journey to the Water. It was at Eco Adventures, and they ran through their booking, and all of the proceeds came back to the hatchery. We took guests to the Eco Fence. I hope it probably doesn't show up well, but the red, closer to Front Road, that is the length of the Eco Fence. And we also snuck in some talks about the snake hibernaculums in there. And also the hatchling tracking study. Again, Lauren Brago's been brought up a lot. She's going to come up and talk about that. And so we'll just continue. And then we also had a few of the tours included a hatchling release down into Turkey Point Marsh. And we also, with the Long Point Land Trust, we ran a tour called Turtle Trouble, and there was a hatchling release at Burning Kiln property. There were about 40 people for there, and they also got the tour of the fence and all of that. And then this last section is very long, and it's just all of the thanks for everyone that helped make the programs work this year. So thank you to the Ontario Turtle Conservation Centre, who took in our injured turtles, and their veterinarian, Sue Warren, who I did see. Hi, Sue. And that turtle on the right is Carrie, is one that Carrie found and rescued, and then took all the way to Peterborough, and then she was ready to be returned this year. So this is her releasing that snapping turtle. And there's Joy's Bakery Cafe. It's a fundraiser in March selling cookies. And she also invited me over to do a book reading, Never Give Up by Jan Everett, of course. And then Brian and Erin Craig, thank you for installing our seasonal watch for wildlife signs that designate our hotspots, get people to know where they're driving. We also had our photojournalist, Sam Stevens, who shadowed our crew for hatchling season and nesting season, and she'll be sharing her photos and her story with us in Canadian Geographic in a couple of years, hopefully. And Dr. Chantel Markle's students from the University of Waterloo, they were amazing to work with, and all the extra hours that they put in chasing turtles with me was amazing. Our turtle tour guides, you should start noticing some familiar faces in here. And of course, Long Point Eco Adventures for everything they put into the hatchery, along with the staff who helped with all the outreach and logistics with the tours and the display. Amazing. Of course, Wildlife Road Watch volunteers. They really went above and beyond this year, not just with road patrols, but also helping at the hatchery. And we did weeding events at the eco fence to make sure it was all ready for the turtles. And this is a fun little story I had to include. So we had a couple of volunteers who donated their time and materials to modify 30 high visibility vests. They put our logo on the front and then the cute turtle on the back. And we also had a volunteer who sewed pockets onto the front. And the vests themselves were donated by Mitchell Plastics in Kitchener. We had the media who ran stories on the hatchery, the Simcoe Reformer, the Advocate, the Hamilton Spectator, and I had a spot on CHCH News. And I have to give a shout out to the Long Point Lioness Lions Club, who did a donation. And there's also Kendall, who is serving the food here, is also a Long Point Lioness. And then, and I hope you'll join us in the muck next year, and long live our turtles.
Thank you, Lauren and Carrie. I neglected to mention to all of the presenters in this session, please take a gift bag as a small token of gratitude. Our next speaker is Rachel Young. Rachel is new to the biosphere. She is coordinating the Other Effective Area-Based Measures Program, OECM, and she, in that capacity, advances the recognition of protected and conserved areas, sometimes called 30 by 30, trying to designate protected lands in Canada per our international obligations. She collaborates closely with local conservation partners, community members, and the provincial and federal government to help Canada achieve its conservation targets. Rachel has extensive experience in ecology. She's passionate about safeguarding biodiversity in ways that both benefit nature and the communities that rely on it. And we are very delighted that she is now part of our team. So, Rachel.
Thank you, Janet. So yeah, as Janet mentioned, I have been with the Biosphere since earlier this year. Is it not? Can you hear me? Okay, is this better? Okay. So yeah, I'm gonna give some updates. Oh, hold on. There we go. I'm gonna give some overall updates on our OECM project, and I'm proud of you, Janet, for saying the full acronym for OECM because I even sometimes myself forget it. Last night at 1 a.m, I did Google OECM to make sure that I know what it stands for, and don't worry, I know what it stands for. So proud of you for that, Janet. So yeah, I'm gonna sort of give an overall update on this project, but to kind of contextualize, I'm gonna sort of lay the groundwork by introducing the 30 by 30 target, because I imagine many here are familiar, but not necessarily everyone. So, and it really sort of does lay the foundation for this program, and it ties into both federal and international conservation targets. So it is sort of a really important baseline to understand for this program. So to start off, what is Canada's 30 by 30 target? So as many of you are probably familiar with the Convention on Biological Diversity and the COP meetings that happen fairly regularly, in 2022 at COP15, Canada, as well as 195 other member nations, adopted a new global biodiversity framework known as the Kunming-Montreal Global Biodiversity Framework. And essentially this new framework outlines kind of overarching goals related to conservation, which aim to safeguard nature and halt and reverse biodiversity loss at a global scale. So this framework, and many of you also might be familiar with the Aichi biodiversity targets, which I think were adopted in a similar manner at COP10 in, I think, 2010. So these are very similar, somewhat of a recommitment or rebranding. But essentially the framework includes 23 specific targets with the goal of these all being met globally by 2030. And target 3, which is commonly known as the 30 by 30 target, is sort of the focus of this presentation and also provides the context and lays the groundwork for the Biosphere's OECM program. So what is this target? So 30 by 30 aims for and calls for at least 30% of the world's terrestrial and inland waters, and also 30% of our marine and coastal areas to be conserved and protected by the year 2030. So there is a little bit of nuance to this target. It's not about just checking a box and throwing numbers into a database and calling them protected. There are some elements to focus on, the quality of conservation in these protected areas rather than just quantity. So more specifically, these protected and conserved areas should be managed through ecologically representative, well-connected, and equitably governed systems of both protected areas and other effective area-based conservation measures. And I'm never gonna say that full acronym again. So from here on out, it's OECM. And so 30 by 30 represents one of the largest conservation commitments that has been undertaken globally. And then the Government of Canada has also committed to this target through Canada's 2030 Nature Strategy, which outlines how the country is going to achieve all 23 of those targets outlined in the Global Biodiversity Framework, including Target 3. So progress towards this, both the global and the national target, is measured by the coverage of protected and conserved areas. And at the national level, this is tracked by something known as the Canadian Protected and Conserved Areas Database. So that map there, that shows currently what is in CPCAD. So as you can see, there is sort of a network of these areas across the country. And before kind of diving into what our progress is at this target, it is important to understand what exactly is meant by a protected area or an OECM. So what exactly is defining these areas, and also what is the difference between the two. So both PAs and OECMs can take many forms. There's your sort of traditional and formal areas that likely are what come to mind when you hear the word protected areas. So thinking of provincial and national parks, national wildlife areas, those sort of, stereotypical protected areas. But there are also some other less traditional areas that can be considered towards this target as well. And these may be areas that include sort of varying levels of sustainable land use, like recreation, education, research, and even sometimes some forms of agriculture. So those areas, as long as the conservation of biodiversity is being practiced, there are other areas that can still be contributing to this goal. So in terms of sort of a globally accepted definition of these two, protected areas are clearly defined geographical areas which are designated or regulated and managed with the primary objective of conservation. So what these areas have in common is that conservation of biodiversity is at the core management direction of the property. It's the primary and overriding objective, and the governing authorities of said properties are able and also obliged to enforce that these management directions are practiced. So some well-known and local examples of PAs in the biosphere region include Long Point and Turkey Point Provincial Park, the Big Creek and Long Point National Wildlife Areas, as well as conservation areas owned by the local conservation authority and nature reserves owned by our local land trust. So again, protected areas are kind of your typical areas that one might think of. OECMs, on the other hand, are areas that do achieve the same long-term conservation outcomes as protected areas, but they will have a primary purpose other than conservation, or at least secondary to conservation. So they still need to be geographically defined areas which are governed and managed in ways that achieve the conservation of biodiversity. However, with conservation not necessarily being that primary or overriding objective. So to give some context, there are some well-known examples in the database. So one of those is a military base in Manitoba. So this is a 21,000 hectare property, and the primary purpose of this property is to deliver military training. However, given the vast size of the property, there's military training happening on a small subset of this property, while the remainder of the property is pristine prairie ecosystem. And there is a management plan for this property, which essentially limits public access. And so you're sort of left with almost accidental conservation just by nature of how the property is managed. These sort of undisturbed, ecologically valuable areas are left alone and thereby conserved. Another good example that some of you may have heard of is the Queen's University Biological Research Station. So again, it's education and research which are the primary purposes of this property. But again, conservation is still achieved. I believe this property is about 4,000 hectares in size. Actually, I have some photos, I think, yeah. Whoops. So the military base there on the top, and then some photos of the research station. So yeah, I hope that kind of helps differentiate between the two. So I kind of like to say sometimes OECMs are like accidental conservation, as is the case with the military base, but it's not always accidental. The Queen's University Research Station also implements best management practices to conserve these biodiversity values on the property, and I believe they do lots of ecological monitoring and that sort of thing as well. So next steps is we understand what defines these areas, but how can an area be officially recognized as a PA or OECM and counted towards this target in Canada and also contribute to our international targets as well. So areas must first be evaluated against a set of criteria and meet the standards for these criteria to be counted towards a target. So there's something known as the decision support tool, which assesses areas against a standardized set of criteria known as the Pan-Canadian standards. And so to qualify, an area being assessed must meet the standards for each of these criteria that are outlined in the decision support tool. And sort of broadly speaking, these criteria consider elements such as whether an area has clearly defined boundaries, whether the governing authorities of the property sort of can and will manage activities within those boundaries that are in alignment or at least don't interfere with the conservation of biodiversity. And lastly, whether there is some type of commitment to manage the area for conservation over the long term. So again, once an area meets all of those standards, it can then be reported to the Canadian Protected and Conserved Areas database, which is then reported to the World Database for Protected Areas. And while all criteria must be met, there are some varying levels of standards for some of them, which help to classify an area as either a PA or an OECM. And again, it really comes down to the primary purpose of the property. So in terms of progress towards the 30 by 30 target, the database only gets updated once annually now. So the best numbers we have are as of December 2024. And so by the end of that year, last year, Canada had conserved 13.8% of our terrestrial and inland areas and 15.5% of our marine and coastal areas. So of course, at the national scale, Canada is still short of our 30 by 30 target. And the country is going to need to essentially more than double these values in the next 5 years to meet the target. But experts in the field do still remain hopeful. So it is believed that with focused and coordinated efforts and action, it does still remain possible to achieve this target in the next 5 years. And here's sort of some graphics to articulate our progress towards the goal. So as you can see, like in more recent years, there has been like a steady increase. And that just sort of, goes without saying that effective conservation does take time. It takes building partnerships, and the progress is occurring. As I mentioned previously, the main metric for progress towards this target is the coverage of protected and conserved areas. So just sort of that mathematical metric of the percent of area covered. But there are further component indicators that are identified as well, including the protected area coverage of key biodiversity areas. So as I mentioned, it's not just about quantity, it's also about quality. So as probably many of us here are familiar, the Long Point Biosphere region is an incredibly important area for biodiversity, a lot of rare and endangered species and ecosystems, and as a result, it represents what the Convention on Biological Diversity would define as an area to prioritize for meeting these targets. So, it's, again, goes without saying that this represents an area where protected areas are very important. So in terms of 30 by 30 in the biosphere region, coordinating regional efforts within this priority area is going to remain essential for increasing not only the quantity, but the quality of effective and meaningful conservation and helping us reach that target. So we've really been sort of honing in on partnering with local partners and local expertise who know the land best and who know the biodiversity in the area best to help identify areas that will matter the most and represent meaningful contributions towards this target. So the biosphere has been advancing regional efforts towards this target by working closely with various local partners to identify and submit protected and conserved areas towards the 30 by 30 target and CPCAD. So within the Long Point Biosphere region, as it stands now, there are 158 protected areas totaling just over 11,000 hectares of protected and conserved areas. And again, the database is updated annually, so we will soon get updated values for this. But as of right now, we have nearly 160 protected areas in Norfolk County, which is great. And then this year, the Biosphere has contributed to expanding this network of protected areas by submitting 12 new protected areas and 2 OECMs, adding a total of nearly 700 hectares to the database. And it's kind of exciting because these are the first OECMs in the county as well. So one of our projects was with the Grand Erie District School Board. So there's a secondary school where, kind of similar to the military base, although obviously very different very different purpose. But it's a sort of a large property, and there's like a school, I think it's like the southwest corner with, blacktop and that sort of thing. But the majority of the property is significant wetlands, and there's lots of recorded species at risk on the property. And it just is sort of this like pristine, undisturbed, untouched area of wilderness. So again, the primary purpose, not conservation. It's focused on education, but they've developed a management plan to help preserve the biodiversity values on the property long term. So it's a really good example of an OECM, and one that we're proud to be contributing to the target. So in terms of next steps in the biosphere region, we've kind of just done a good job of submitting all of the well-known protected areas in this area to the database. So again, kind of looking at like your typical protected areas, they're in the database. So we are very excited and happy to continue collaborating with local conservation partners to get new properties into CPCAD as new properties are acquired. But in terms of existing properties in the county, most of them are in the database. So where does that kind of leave us with for next steps is to identify new opportunities as well. So something I've done for a few years in my career now is worked with community members and individual landowners who are passionate about conservation and want to contribute and make a difference kind of at an individual scale. So something the biosphere is beginning to investigate is launching a conservation easement agreement pilot project. So essentially, this would involve engaging with local landowners who would like to ensure that their properties are protected in perpetuity, while also still being able to, maybe live on their land or use their land for agriculture or whatever purposes they're using their property for. But at the same time, ensuring that their properties will, not get developed 100 years down the road, something to be said about a living legacy, if you will. So those are kind of the next steps that we're looking at. So conservation easement agreements kind of allow for this by sort of placing restrictions or covenants on a property related to, you can't tear down this old growth forest, that sort of thing. And then with those protections, it would allow a property to then qualify as a protected area. So those are sort of the next steps and next avenues that we're looking at for contributing to 30 by 30 in the target. But also if there's anyone in here who has land they want to put in the database, feel free to find me and we can get that done. That's all. And I'm not sure, I imagine we don't have time for questions, but feel free to find me later if you've got anything burning on your mind. Thank you.
Our last speaker, but certainly not last but not least, is Sarah Emmons. Sarah Emmons has been working on the Norfolk landscape since she completed her Master's of Science research in a swamp in Frogmore. So I'm sure she can explain that. Okay. Sarah's been the conservation director with the Biosphere since 2022, and she previously performed the same role that Rachel now does with the OECM project. But currently she is managing the newest of our projects funded by the Canada Water Agency called the North Shore Resilience Project. So this is a major project that stretches across a number of municipalities, including Norfolk County, looking at ways of building coastal resilience, both involving science as well as some stewardship activities. And her second job is as a municipal councillor in Elgin, which makes her uniquely qualified for the project. So Sarah, please come and tell us about the project.
Great. Thank you. I've spoken before about the North Shore Resilience Project here, And this is year 2, so I'm going to move this down. I'm very short. Okay. This is year 2, and I just wanted to mostly give everyone an update on the project. I'll do a little bit of the background stuff, but this is more an update of what we've accomplished in this year and what we will be finishing off in in this kind of federal fiscal year ending in March of 2026. So, there we go. So as Janet mentioned, this is a project that's been funded by the Canada Water Agency, and it's in response to serious threats to the North Shore of Lake Erie from Port Glasgow to Long Point. This was identified through a government white paper, I think 6 years ago, and since then the Canada Water Agency has been putting together a lot of these coastal resilience projects throughout Ontario. There's one in the Maitland Valley, Peely, and Rondo, because unfortunately a lot of our coastal regions are facing some pretty serious threats, and most of them are facing increased erosion. And that, mostly all for the same reason. Climate change is a big factor. Even just thinking about it, on a surface level, we're not seeing the coverage of ice on the Great Lakes that we used to, nor the number of days. We're seeing a lot more ice-free days in the Great Lakes. And when you think about erosion on the coast, that means that all of those eroding bluffs and our sandy points are exposed to wind and water energy for a much greater portion of the year than they used to be on average. We also have a lot of anthropogenic factors, such as the disruptions to natural sediment transport within the cell. These can include, some of our infrastructure and our coasts and our harbors and our ports, but also a lot of shoreline hardening that is often in the response to erosion. People want to protect their homes or infrastructure, but unfortunately that does increase these disruptions to sediment transport. So right now, we don't really have the technical information to really understand what's happening with sediment transport in this littoral cell. And it's a really large area. Our littoral cell starts all the way in Port Glasgow, which is in West Elgin. That's the very farthest point of Elgin County. It's almost in Chatham-Kent. And so all of the sediment that erodes from the bluffs on the eastern side of Port Glasgow should end up, in places throughout the littoral cell, but a large quantity should end up at Long Point. This is our depositional area. It's a sand spit formed, with all of this sediment. And everything that's west of that actually goes to Rondo. So the whole coast is made up of these littoral cells, but ours is a really big one. And that makes this project like a really large project involving a lot of players. When you think about the number, of different government agencies that are all kind of participate in managing the coast, and you look at a geography like this, you've got federal agencies like Small Craft Harbors. You have 7 different municipal governments because Elgin is still a two-tier municipality, and you have 4 conservation authorities. There are 2 First Nations, in this area as well, who are, treaty holders. And not to mention that each community, is its own little area. We all have our own little culture. Southwestern Ontario is certainly a diverse place, even, Port Burwell is a lot different from Port Bruce, and certainly different from Long Point. So the goals of this project, I'll kind of I've divided them into these 3 kind of big goals. And the first is to develop that technical and scientific knowledge. So we need to be, collecting physical data and developing a sediment budget and a transport model to better help us determine how much sediment is eroding off of the bluffs, what's coming out of our river valleys, and how it's being transported along the coast, and where the sediment sinks are. So that is a lot of physical collection of data, and then we have some really smart computer modelers, that is not me, who will develop the sediment transport model. We are completing dune restoration projects to build coastal resilience in a kind of active community-driven way as our kind of like our boots on the ground portion of the project, the stewardship portion. And then the ultimate goal is to take that technical data along with participation from all of these government agencies and the communities, the various communities located throughout the cell, and produce a resilience action plan so that we make sure that any actions that are recommended encompass not only the physical data, but also feedback in terms of the social, the social and economic and environmental factors that feed into this. So I'll just talk a little bit about some of the work in a little more detail that's gone into developing these goals. And there's been a lot of physical data collection happening to support the sediment transport budget. So this is an example of what a sediment transport budget kind of ends up looking like graphically. You want to really quantify how much sediment is eroding from the bluffs, in those red lines, where it's being transported into the near shore, it's being transported along the near shore, and then where are all the various sinks? Because there's not just Long Point, there's various sinks along the way. And you also want to make sure to quantify the sediment supply from the rivers as well. So the physical data that's collected as part of that, first of all, you want to do the bathymetry. So this summer and last summer, we take a boat, it's measured with sonar, it just measures the depth to the lake bed, and you basically create kind of an underwater topographical map. So there's the transects. Sorry, every time I move, I don't. The transects you can see in those kind of rainbow lines up there, that's in Port Stanley, and that's the tracks of the boat. So it was very detailed bathymetric surveys in all of the harbors, and then along portions of the coast as well. And so this particular graph comes from a site in Southwold, and that's part of the eroding bluffs. And if you can take a look at the graph, you can see that we've got a measurement of the estimated, what we know the bluff is now, and then an estimated, the estimated position of the bluff in 1980 from historical data. So you can see that there's clearly been erosion over time, on the bluff, which is normal and expected. But we can also see from this data, we're using the some 1980 data from the Canadian Hydrographical Society. That's physical bathymetry that was taken in 1980. And then we are comparing that with some data from 2020 and 2025 that we have taken using the sonar. And it's obvious even at this scale that you can see that we're not only just eroding the bluff, but there's erosion happening along the lake bed at the toe of the bluff over time. And you can't, the scale isn't big enough if you kind of zoomed in. It's even quite visible that there is erosion happening from the 2020 survey to the 2025 on that lake bed. So then we have we go out and we also need to characterize the sediments that are in the lake bed. That helps us to determine, how those sediments are moving throughout the cell, because of course, silt and clays are going to move in a different way than sand does because of, the grain size and the shape and the density. So these samples were taken off the tip of Long Point, and I'm sure many of you people have been out to the tip of Long Point, and everyone knows that there's this big shoal out there, right? We've got a lot of sand deposit happening off the tip of Long Point. And we're not really clear on why that is. It would be a lot nicer if that sand was being deposited along Long Point, because we are certainly losing area, on Long Point over time since 1960. On almost every part of Long Point, including the coastal wetlands, over that long period of time, you can see erosion and loss. And so one of the kind of big mysteries that the technical people talk about a lot is, why is this being deposited in that shoal? So we did the bathymetry there, and we also take sediment samples. We do that with this grab sampler. It's almost like a Pac-Man that drops to the bottom and grabs a bunch of sediment, and We pull it up, it's really heavy, and I make Pete do that part. And then we basically bag up the sample and send it off to the lab for analysis. So that's another portion of and again, we're doing this in a lot of spots. So that was a lot of kind of physical gathering of data that happened this summer. And you really, in order to build, a really, the most accurate sediment transport model that we can, this data is really critical. This data will significantly improve the accuracy of the sediment transport model. So in our goal number 2, which is the dune restoration part, that has been taking place throughout the littoral cell, but the most of it has been happening on Long Point. And in order to correctly restore dunes, we want to have the right plants. And a lot of the beach grass that has been used in the past to do dune restoration across the Great Lakes, actually, not just in Lake Erie, but all up the shore of Lake Huron as well, is actually an Atlantic variety of beach grass. And so Pete Zuzek, who is the main partner from Zuzek Inc. on this project, he actually had the Long Point beach grass and some of this stuff that he found in Sauble as well, genetically tested against those Atlantic varieties, and they are separate species. So we wanted to make sure that we had the correct species to do this. We were able to get a permit from our partners at Canada Wildlife Agency to collect 2,000 native beachgrass plants. These were from very high density colonies that we found at Long Point, so it was not going to impact the health of those colonies. And those needed to be collected and then planted within 24 hours. And I really want to thank our partners. You can see how many people were involved in doing this work. NCC was there, their staff was helping us out. They actually let us use their big boat and boat us out there. And Canada Wildlife Agency or Canada Wildlife Services was also there as well, helping out. So that was a super fun day, and I just want to thank our partners for that. That's just a shot of the collection site there, and you can see in the inset photo in the top that it's quite a dense colony. So this did not harm the colony in any way. And so we were able, since last fall, so it's really just one calendar year, we had 16 private landowners along Beach and Woodstock Ave in Long Point volunteer to participate in this program. And we planted the Great Lakes beach grass, little blue stem, switchgrass, cottonwoods, and cedars. And I've been really, really pleased with the uptake that we've seen on Long Point. Kind of a lot of culturally, Long Point, we're very used to seeing bulldozers and really fully clearing the beach. Certainly the bulldozers will probably always be there. There's a lot of inblown sand to people's homes and cottages in the spring, but it's really wonderful to see such excellent participation from the Long Point community. We are also doing dune restoration on municipal land, and that comes in the portion of in the form of these municipal walkway projects. So you may have seen our project at the Austin Parkway walkway in Long Point, and oftentimes our walkways are fairly wide in Long Point, and that really just encourages like a wind tunnel of sand being removed from the beach and blown inland. And we really want to keep it on the beach. Landowners, private landowners are, again, they really suffer from a lot of inblown sand, and this can help to protect their homes as well and private properties. So I found that these projects are really well accepted by the neighbors, and people really want to have them. I don't think we'll have enough funding to do all the ones that are wanted actually in Long Point. And then we do plantings behind the fences. We narrow the path so it's this kind of S-bend, and that helps again catch that sand and build the dunes. And we put up signage to ask people to stay off the grasses as well. And a lot of times there can be some conflict in Long Point between the regular beachgoers, the public, and these private properties. And so the private landowners have been really happy that these fenceways really prevent a lot of that conflict. as well. And, oh, and then we've not only just done this in Long Point, but even this fall, we had participation from 3 other municipalities as well. And I think we'll probably have one in Central Elgin in the spring. So again, this is something that's being done across the littoral cell. I want to thank Peter and Mary for helping with the seed propagation. They had us out to their farm, and who knew that you could extract seeds using a blender? That was a new technique. So thank you for that. They've also been very helpful for this project. We gather a bunch of seed when we're out at Long Point, and we've been kind of just doing some home propagation. So you can see we've got those little mini grow lights there. Pete and I just started growing it in our kitchen, last year. And now that we've gathered a lot more seed, Mississaugas of the Credit First Nation have agreed to partner with us and propagate beach grass, just in their own homes in the same way, using these micro nurseries with grow lights. So that's a wonderful partnership. And Prairie Song Native Plants, they also have been the ones supplying all of our plants for our dunes. They are also, we took some of the beach grass that we removed from Long Point, and we have planted it in an inland nursery there. So we're trying to develop, multiple different ways to propagate and grow the beach grass, because obviously we can't just keep going back to Long Point and taking these plants, right? We need to start getting it going throughout the cell. And then there is this Resilience Action Plan portion, and this is the community and governance portion of the plan. So we do need to develop a Resilience Action Plan that respects all 4 dimensions of the coast: the social, the economic, the ecological, and the physical. And so that requires a lot of public engagement and a lot of engagement with all of those government agencies that I spoke about earlier. And it requires technical review as well. So we have 3 different kind of governing bodies in this project. And the first is the Technical Advisory Committee. We want to make sure that all of this technical data that's been developed and all the modeling is indeed technically sound. So we have a bunch of really smart people, experts in their field, who are helping us with this. We had a coastal retreat with the Technical Advisory Committee. In that picture, you can see Pete Zuzek. There's Jody McKenna from Canada Water Agency, Dr. Ryan Mulligan from Queen's, and Dr. Chris Hauser from the University of Waterloo. And these are coastal scientists, coastal engineers, and that's not the whole committee, but this is the group that we have, making sure that this data is indeed peer-reviewed and sound. So they are going to be meeting again to review all of the final technical data, and then that review will be passed on to the other portions of the project, the other governing bodies, so that they feel confident that this technical information is correct. Then we have our Public Advisory Committee. This committee has been assembled over the course of the last year. We have an arm's length consultant who runs the Public Advisory Committee to ensure neutrality. And again, we've done a coastal tour with them. We have virtual meetings. Our next in-person meeting is actually next Saturday. And they will be coming together to then review the technical data that, again, has already undergone technical review, and provide input from a community perspective, again, those socioeconomic reviews, and really provide local input, because again, this is a very large geographic area, and everyone has their own issues in their own community, and we want to make sure that there is a lens to that. Then we have our working group, and that is made up of all of the municipal governments. So there's 7 municipal governments. Currently 6 are participating, but actually I think after Monday night we're going to have all 7. There's a report going to the Central Elgin Council to recommend participation, and I feel confident that I'll have collected them all after Monday night. They're like my infinity stones. And we have Mississaugas of the Credit First Nation who sits on that. We have, again, federal government agencies like Small Craft Harbors, and we have all 4 conservation authorities participating as well. So again, it's the same kind of process. We meet several times a year, And they will also be, once the Public Advisory Committee has reviewed the data and the Technical Advisory Committee has, then it goes to the working group. And they're going to really develop those final recommendations for the Resilience Action Plan. So the actual Resilience Action Plan will be ready in March 2026. And we will have open houses throughout the littoral cell with all of the technical results and the Resilience Action Plan to be released to the community. And you can find out more at northshoreresilience.ca. Questions? We're not very vocal today as a group. Okay. Oh, yes. Mm-hmm. Right. So though we don't know what kind of, it might not be structural, right? There's a bunch of different actions that are kind of built into littoral cell action plans. Sometimes it's like structural. Sometimes like based on infrastructure and things, but sometimes it can also be things like taking, sand where you have somewhere where you don't need the sand or you don't want the sand, and moving it to a place where it'll downdrift and deposit into a place where you do want the sand. Okay, all right. So not kind of infrastructure structural, but yes, that's right. It can be structure. I'm sure dune restoration will be one of those that's recommended also. But there's a number of kind of a wide variety of things that can be done to build coastal resilience. Yes, yeah, it is. All right, good. Oh. To do our dune grass, spring or fall, for sure. You don't want to do it any other time than spring or fall. Such sandy soil, and we want to make sure that it gets its roots down when things are still wet. So normally that is, definitely there are event-based, like you don't, when we talk about erosion being 4 meters a year. And by the way, this littoral cell has the highest levels of erosion in the Great Lakes. When we talk about it being 4 meters a year, you're certainly right. You can have these big slumps that happen overnight as the result of an event. But what we're really usually looking at is change over time. And there's just, from my understanding, trying to capture event-based is something they try to do, but it's almost impossible. One of the ways that Dr. Hauser's lab has been doing that is these coastie camera stations that they've got set up, where you can come and take pictures and submit them to a database. But I know that they have had several cameras positioned to try to capture one of those events for the before and after. But yeah, that is very challenging. But from my understanding, you don't need those event-based data to actually build a sediment transport model. It's okay because you're measuring change over time. We are working with Canada Water Agency, who is indeed a nature-based solutions sort of organization, and they're also certainly, those are extraordinarily expensive interventions, right? Like extraordinarily, and oftentimes like things that you'll be like, oh well, if you just do this, because I've had it explained to me by the coastal scientists that indeed there are it's very hard to almost predict those, and it doesn't necessarily work the way we intuitively think it might. Yeah. As a Dutchie myself, yes, I agree. The Netherlands has, and actually, their big project is a sand engine, similar to kind of ideas that have been tossed around for Long Point, and it is this massive project, and it's really inspirational. And I know that Pete brings that up regularly, the Dutch sand engine. So. Yeah. Thank you, Dole. So most of the areas that we've been planting do not have a Phragmites infestation, but a couple of them do. So Port Bruce and Port Burwell. But you know what? The municipalities have been so lovely to work with, and most of them are used to spraying their roadways at this point. Elgin is kind of in its medium stage of building their Phragmites response program, not like Long Point. You guys are advanced. But they are used to doing the spraying, and they actually have sent their staff out to help us in a couple of cases. So yeah, the municipalities are really partnering well with us for Phragmites. Yeah.
Angela Vander Eiken is the Landscape Conservation Programs Manager at Georgian Bay, Menindo-Gambier Biosphere in Parry Sound, where she has spent over 4 years managing programs focused on biodiversity, conservation, and stewardship across eastern Georgian Bay. Originally from Southern Ontario, Angela has a background in environmental engineering and restoration through her work with the Conservation Authority, bringing both technical and community-based perspectives to her role. Her research interests include landscape-scale conservation and breeding approaches to land and water stewardship. Angela will be co-presenting with Dr. Brandon Van Heusen, postdoctoral fellow with the University of Waterloo's Wildlife Ecohydrology and Conservation Lab, which is supervised by Dr. Chantel Markle. Brandon's work focuses on integrating ecohydrological, geospatial, and environmental modeling methods for habitat mapping, natural asset management, and data visualization to support community-led conservation initiatives, such as how wildfire, flooding, and drought risk impact ecosystems' suitability for species at risk. So everybody give a warm welcome.
Thanks, Jessica. So we're just going to get started. It's so nice to be visiting here at a fellow biosphere. As Jessica mentioned, we're from Georgian Bay area. And Brandon and I are really excited to be chatting with you about a new project we've been working on recently called the Natural Asset Management Planning Project, or NAP for short. So before we get into it, I'd like to introduce some of the folks who have been working on the project for the last year and a bit. My name is Angela Vander Eiken, and I work at the Georgian Bay Menindo-Gambier Biosphere. As well in the GBB team, we have Greg Mason, Director of Operations, as well as Emily Holdsworth, who is a GIS technician with GBB, but also with the local geography network. There we go. Also working on the project is Dr. Chantel Markle and the Wildlife Ecohydrology and Conservation Lab at the University of Waterloo, and Dr. Brandon Van Heusen, as well as PhD student Waverly Birch. Not pictured here, we also have Matilda Kim, who recently just joined the project as an intern. And then we're working with McMaster University with Dr. Mike Waddington at the Ecohydrology Lab and Alex Furukawa, PhD student. So I'd like to begin by acknowledging the land in which I live and work in the language of the original caretakers, the Anishinaabe. Georgian Bay, or Menindo-Gambier, means Great Lake of the Spirit and reflects the deep connection between people and this place. The region falls within the Robinson-Huron Treaty Territory of 1850 and the Williams Treaty Territory of 1923. And it's home to 6 First Nation communities. You can see there on the map in that kind of beigey color, with others, many other communities holding traditional territory here as well. So a little bit about the Georgian Bay Biosphere to start off. As many of you may know, Eastern Georgian Bay is known as the 30,000 Islands. It boasts the world's largest freshwater archipelago, and it's one of 19 biosphere sites across Canada. Our region covers approximately 347,000 hectares, including almost 200 kilometers of coastline from the French River in the north to Port Severn in the south. As you can see from this map, our region includes a lot of First Nation communities as well as protected and conserved areas. And this diverse landscape is also home to more than 60 species at risk. So we were designated a UNESCO World Biosphere Region in 2004 to recognize both the ecological significance of this place as well as the cultural importance. So as a biosphere, our focus is on learning how people and nature can live in balance. And as I'm sure everyone here today can attest to, Biospheres are often called living laboratories. We're continuously exploring ways that we can deepen our understanding of the landscape. And one of the main reasons why we want to be able to better understand our landscape is so that we know how to care for it. Essentially, where should we be focusing our biodiversity caretaking efforts? One way we've looked into this question and answering this question is through our State of the Bay program that you can see pictured here. It gets updated on a 5-year cycle and highlights key environmental trends and collective efforts that are happening across the coast. It includes a lot of nerdy content and research as well, but it also really highlights the work that partners are doing for stewardship too. While we know a lot of things are happening along the coast, though, we still face a critical challenge of being able to determine where we should best focus our caretaking efforts. Fortunately, mapping is one of the most powerful tools that we can use to better understand our landscape and prioritize our stewardship actions. There's many different types of mapping out there, and various groups have already produced some amazing data sets. However, unlike other parts of Ontario, like for example here in Southern Ontario, the habitat mapping that's available in our region is still not as detailed or as accurate as we need it to be in order to conduct those landscape scale biodiversity assessments. And that's especially critical when it comes to habitats for species at risk, such as for turtles and snakes, so things like wetlands and rock barrens. So let's see what I'm talking about by having a look at some of the existing land cover data sets that we have access to in our region. And to start that, we can look at this example here along the Key River, which is at the northern end of the biosphere. And we'll focus on this beaver dam feature located here. So first, we can see it through the aerial image on the left of the slide. And you can see that dam clearly marked there with the red arrow. Now let's compare that to the Ontario Land Cover Compilation version 2 data set. You'll notice that parts of the wetland system are actually being misclassified as agricultural land, and there's many treed and shrubbed areas that are missed entirely. Now we can have a look at another data set, the Forest Resource Inventory. So this Forest Resource Inventory, or FRI for short, does a much better job at capturing the habitat types, but it still classifies things quite coarsely. So when we compare that to the aerial image on the left, we can see that it still misses a lot of things like certain wetland types that appear to be more fens, that it's just kind of broadly classifying as marshes, as well as shrubbed and treed rock barren areas, which are actually being labeled as rock. You can also see in the bottom left, so this green here, that polygon there, it's being picked up as a forested habitat type, but it's actually likely to be shrubbed or treed rock barren. Because the FRI product is meant for forestry applications, it tends to overestimate tree cover and underestimate wetlands and rock barrens, which I mentioned are really important for species at risk. It also does not cover most of the islands in Georgian Bay as well. And many other data sets don't do that too in this area. So in summary, it can be difficult to answer our original question because we simply do not have good tools to work with. There's many limitations to existing data sets available through open source websites, such as the fact that they're often outdated, biased towards specific objectives, spatially restricted, or have insufficient spatial precision and accuracy. In general, there's a better need for us, a need for us to better understand our landscape, and we need habitat and ecohydrology mapping tools that can accurately capture dynamic changes over time with greater precision and accuracy. So to address these challenges, we've been having conversations with First Nation communities, municipal planners, researchers, the Land Trust as well, who's in the room, and the West Prairie Sound Geography Network to develop tools that better support biodiversity conservation in the region. And we've begun doing this through a natural asset management planning approach because it aligns with municipal standards and helps integrate nature-based solutions into planning and decision making. So our overarching goal with the NAMP project is to develop a habitat mapping database that will accurately allow us to be able to better understand natural assets and climate risks in the region. And the region I'm referring to is the entirety of Eco District 5E7, shown here. It's actually about double the size of our biosphere. And it will also include the intersecting boundaries of all municipalities as well. The total project area is about 7,500 square kilometers. And that database will provide the necessary information and tools to enhance land management, research, and stewardship efforts. So we're planning to carry out this project over a 4-year timeline. So far, we've had a great first year and a half of conversations and collaboration with partners across the region. We've established a steering committee as well as technical working groups. And we're planning to continue engaging with partners and refining our additional outputs throughout 2026. The NANT project's a little bit different from some other natural asset inventory projects happening in Ontario because we're working with partners from the outset to create and refine our own new data set instead of relying on existing land cover data sets. This ensures we have accurate and trusted information about the location of condition of habitats from the beginning. It also includes 2 seasons of ground truthing that we're doing in collaboration with partners, along with the development of a habitat model that Brandon will be talking more about, and a suite of associated tools such as reports and online dashboards. And then in 2027, we plan to focus on mobilizing this knowledge with partners and supporting the integration of these planning tools and stewardship tools with partners. As you can see, we're currently in the second stage of the project, which I'll go over first in kind of a high-level detail, and then Brandon will get more into the nuts and bolts of it. So getting a little bit into the habitat mapping process, first we started working with Waterloo and McMaster to compile current data, create a baseline repository, and identify data gaps. Waterloo and McMaster then got started on developing a habitat mapping process, and that's based on multiple trials and iterations, and also in collaboration with those regional technical experts that I was talking about. After this, we started collecting additional ground truth data to input into the model. These data sets are being used in the model to create and verify updated derived data sets of land cover, so to create spatially accurate maps of habitat types. Now, the really important part is the process doesn't end there. Based on additional ground truth data that we're collecting, we will continue to refine the habitat mapping process and work to improve its accuracy. And then you can see highlighted in orange here is the iterative part of the process. So with the support of partners and this being really a truly collaborative process, mapping outputs are going to be continually refined and updated. So the habitat mapping process also ties really well into data sharing process. So we reached out to partners first to gather existing ecological land classification data sets. We provided financial support for that, as well as we co-developed data sharing agreements to clearly define the data use and protocols for sharing. Then, as I mentioned previously, those existing data sets are getting fed into the computer model to help train and verify that model, and that's something that Brandon will go a lot more into detail than I am. This past field season, we also worked collaboratively with interested partners to collect new ground truth data sets through a standardized data collection form, which I'll go through a little video of how that looks after. And we did also training sessions with partners too. For First Nation partners who were interested in collecting data on their reserve lands, we co-developed memorandums of understanding, so MOUs, to outline the roles as well as the responsibilities for long-term data sharing protocols. And then once we have incorporated both of those kind of existing and the new data sets into the model, we'll conduct further partner engagements and establish new data sharing agreements before the actual end result data set is shared. And when we do that, First Nation communities or others who have the habitat mapping on their land, they'll get a copy of that, and it'll be up to them if they want to share that data broadly. And if they do, that will be governed through data sharing agreements. To guide our whole approach and to also train our team on this, our team and project partners have completed OCAP training, which is Ownership, Control, Access, and Possession for First Nations Data Sovereignty. And this learning has really helped in our engagement with First Nation communities, managers, and consultation staff to help us better understand their expectations and goals around data access, sharing, and storage. So I'm going to pass it over to Brandon now to go over the modeling.
Thanks, Angela. Can you hear me, everyone? Yeah? Okay. So the actual habitat classification model, as you can see here on the right, it's going to be for a very, very big area. We're going to be using remote sensing techniques as well as machine learning approaches. And the basic building block of the model is what's called a raster. So for those of you who don't know what a raster is, think of a digital picture where every pixel has a numeric value that represents something on the landscape. In this case, it could be the intensity of the green colors or the red colors, or it could be elevation, things like that. And then a stacked raster is taking all of these different variables, whether it's vegetation, whether it's elevation, again, whether it's color, and stacking them all together. And that is the main input, one of the main inputs into the model. And so what is the model itself? So the model is a random forest model, and it's used to predict land cover type based on predictor variables, where the predictor variables are all those variables I had just mentioned. And the way it works is it uses training data, so all the ground verification data that we've been collecting over the summer, and it overlays it with our raster data. And so if we have a training area that says this is a wetland, the model looks at all of the pixel values associated with that wetland, again, whether it's elevation, whether it's the color, whether it's different sort of indexes that I'll mention briefly later, and says, okay, this combination of values tends to be associated with this type of wetland. And so predictor variables themselves will represent vegetation, water, and local topography. And so to do that, as Angela mentioned, there's lots of different land cover classes that are out there, and we're aiming to classify habitat types under the three main buckets, but we want to go much more detailed than that. So maybe in sort of an initial sort of cursory analysis, wetland, terrestrial, and aquatic might be the only classes you need. But if you want to go a little bit deeper, then we want some more classes. So that could be ephemeral pool, getting into differentiating between the different wetlands that are actually out there. Again, pulling out actual rock barrens as opposed to just classifying them as forests if they have trees on them, right? The next class that we're hoping to get to is actually differentiating between, peatlands as well as the different types of forests. Now we're starting to get maybe into some of the morphological differences in the vegetation itself. And for myself, I'm trained as a hydrologist, and I might want to stop here at bog and fen if I want to study peatlands or classify the different peatlands, but an ecologist might want to know, okay, well, what types of vegetation are actually in those different bogs? Is it shrubby? Is there actual trees there? Is it more of a swamp? Things like that. And so the goal is to get to this 27 class layer and produce a map that is as detailed as the classes that you're seeing up there. So how do we do all that? How do we collect enough training data to be sufficient for predicting a land cover model at a 1 meter squared resolution for 7,500 plus square kilometers of area? And the short answer is it's lots and lots of field work. And so these are some of the images here that you can see. We had lots of crews going out, and Angela's going to do a little demo next and kind of go over what that process looks like.
I'm gonna restart it.
Yep.
No worries. So yeah, we just did this screen recording the other week actually, so that we could actually show people, because people are like, oh, you're out there collecting habitat data. How are you doing that? So we had our GIS technician basically develop a form in field maps. And this is what it looks like. This is a quick demo. We're basically delineating an open aquatic habitat. You can see the picture I just took of the habitat there. And we're walking that boundary of that habitat right now with a really accurate Juniper Geo GPS. So you can see our accuracy is ranging between 30 to 50 centimeters, depending on the tree cover. And you'll see as it starts to go along that you'll notice that, oh, that looks like it's land, but that's actually, when I was there, that was fully covered in water. And so, of course, at this time of the year, we have a bit of fall re-wetting, so it's a bit higher for the water levels right now. But this is what it looks like in the form afterwards when you're done walking around the whole wetland. You can also do it just based on aerial image, but since we knew it was different than what the aerial imagery was then, we did it by walking it. We can fill out a bunch of information in the form here, like were there other types of habitat types contained within. For example, we had some treed rock barren islands contained within that. And then we can also fill out the dominant vegetation information for the actual habitat polygon that we're delineating. So I filled out 4 dominant species. That's what the polygon looks like
after it's done being drawn or delineated. And then that's kind of a quick screen recording of the surrounding landscape where we've delineated other habitat polygons. And you'll also notice there's a couple of little dots that show, there's one that shows like a paw print. That one is a wildlife observation. There's a lot of species at risk reptiles in this area, and so were observations that were recorded there. And then we can also record human and natural disturbances too on this data collection form.
Yes, so we're actually thrilled to share that our first field season was a resounding success. So the purple highlights there, it's kind of hard to see because it is a really big area, so the training data maybe doesn't look like it covers that much. So I highlighted them again in purple boxes. You can see we had a pretty good coverage all the way up to Killarney Provincial Park, down to Honey Harbor, as well as sort of east and west around Parry Sound. Lots of different cool landscapes that we're seeing. There's some images there showing that itself. And so a total of 38 plus square kilometers were totally mapped. 1,100 plus habitats were recorded, 156 disturbances were documented, and 92 wildlife observations were noted. So the next question is, okay, how do we process all of this data, right? So if we're going back to that concept of a stacked raster, you can see here on your left, right? Each of those rasters represents some sort of different predictor variable. And again, this is all at 1 square meter resolution, which means that if our study area is 7,514 square kilometers, that's over 97 billion data points that at some point have to be processed by a computer, not a laptop, because it would probably blow it up. So different modeling solutions that are out there. The one that we're using for this project is a high-performance computer called NIBI, which is a word for water. And it's a general purpose cluster of 134,400 CPUs. Okay, this is housed at the University of Waterloo. For reference, a typical laptop is 7 or 8, maybe a high-end performance computer at home would maybe be closer to 32. So we can't leverage all of that at the same time. We have to share those resources with all sorts of different people who also have access to the computer. But it can really help in speeding up the data processing. And so the goal is to basically run all of this through that computer and then come up with an output.
And this is the first iteration of the output for a pilot area just north of Parry Sound. And the university team, as Brandon had mentioned, have worked on that so far. But it's an iterative process. But so far, early results do indicate a high level of accuracy at 0.92. And then when we compare that to the existing FRI data set that I had been talking about earlier, you can see that this new data set is a lot more detailed. In about 1.5 to 2 years, once the mapping model is finalized and approved, we plan to make that data publicly available through a dedicated platform that will allow users to basically view, download, and access the regularly updated habitat data. This is also another just yesterday created output that shows the second subclass classification. So it was the one before the really detailed list that Brandon went over for an even larger area of about 700 square kilometers. And that's, to put in reference, that's all of Seguin Township in our area. So we hope that the resulting data and tools will help a variety of practitioners across the region by providing better information and tools that they can use to, for example, develop best management practices for species and habitats. That may be through things like road work, construction, or development, as well as supporting municipalities in strengthening their natural heritage systems planning, which is not quite at the level as it is maybe in Southern Ontario currently. That will help them align to the guidance under the provincial policy statement, as well as potentially updating environmentally sensitive or environmentally protected zones. As well, we can help provide tools to provide screening tools for environmental studies, helping to streamline development application reviews. And finally, we want to be able to identify areas for future monitoring, research, and climate change adaptation. And this connects really well with Waterloo's goal and research priorities, as well as our shared goal of making this mapping a valuable tool for practitioners in the biosphere region. So the refined habitat mapping will act as a really strong foundation for us to further develop other tools that will support conservation and land management. So we've been working with partners to identify some priority tools, and some of those include things like candidate significant wetlands and wildlife habitat mapping, as well as species at risk connectivity tools. And we're also exploring other related tools that partners are really interested in right now, and that's flood and fire risk mapping. Basically, there's been a really strong interest given future climate projections and the things that municipalities have to deal with on a daily basis. So it could include tools for emergency management and climate adaptation, BMPs, for example, like beaver pond management, culvert sizing, fire response planning, as well as sustainable development and safety planning, and of course, more research applications as well as wetland modeling and assessing potential impacts to species at risk. So we're continuing to collaborate with partners to gather their feedback and refine those ideas to ensure that they truly meet the needs of the region. So we have about 2 years to go before we have a finished refined habitat mapping layer. And some of our next key steps include continuing to engage with partners, keeping them updated, and also keeping those technical working groups going to continue to refine those outputs. As well as Waterloo and McMaster, as Brandon mentioned, are going to be doing QA and QC of the data this winter, and they'll be further testing and refining the model for the entire region. So not just a small chunk, but that computer's gonna be doing a lot of work. Brandon has also applied for additional funding to conduct fire risk modeling for peatlands, and a PhD student at Waterloo has also applied for funding for braiding knowledges approaches for First Nation communities to better understand and integrate their priorities for habitat significance. And then once the first iteration of the model is complete, we're planning to draft a natural asset inventory style of report. It will have natural asset inventory components to it, but we're really hoping that it kind of takes into consideration the needs of the region and kind of broadens that approach. We'll also conduct collaborative ground truthing again in field season 2026. And we'll be focusing on gap areas. So there's a couple areas in the north we want to focus on, as well as some key habitat classes like ephemeral pools, which are have a very short window of when you can actually capture those. And lastly, we'll continue discussions to scope data hosting and sharing options, as well as develop those climate risk tools.
Up next, we have Lauren Rego. Lauren is a master's student at the University of Waterloo in the Wildlife Ecohydrology and Conservation Lab. She is co-supervised by Dr. Jackie Litzkus and Dr. Chantel Markle with her thesis research focusing on Blanding's turtles, overwintering, and habitat selection. This summer, she worked in the Long Point Biosphere region, conducting road mortality surveys of herpetofauna and tracking hatchling snapping turtles. I don't know why that's happening. Sorry for your ears. All right. There we go.
Okay. I'm also a little bit short here. Okay. Okay. Can thank you. Okay, so sorry for the technical difficulties. We have lots of pictures and some videos of hatchling snapping turtles, but I'm very grateful to be here and very excited to present our work on hatchling snapping turtle survival and spatial ecology. And so our study species is the common snapping turtle. And snapping turtles are considered a species at risk, so they're designated as special concern. And their life history strategy contributes to this vulnerability. They're long-lived, and they reach sexual maturity at around 15 to 20 years old. And they also have low recruitment rates. And this can be attributed to different factors such as nest predation, something that Carrie spoke about, especially in areas where predators are subsidized by humans, and also high mortality rates of hatchlings. And previous studies have mostly focused on adult snapping turtle ecology, and what we wanted to explore was the cryptic life stage of hatchlings. And so we looked at their survival and movement in the first few weeks of life. But before we can have a healthy hatchling, we need to have hatch success, and this leads us to the importance of nest sites. And nest site selection can influence embryo development and hatch success, and these main environmental conditions include temperature and moisture. And snapping turtles, they require nests that are deep enough for them to lay their eggs, and also well-drained substrate and open canopy cover so sunlight can access the nest site. And in natural nests, they experience different fluctuations and variation in temperature and moisture. So throughout the day, nests will be warmer and they'll be cooler at night. And then they'll also be wetter after rainfall, so you can see the peaks in soil saturation after rain events. And it can also vary annually. So like this year, the nests were quite dry. And that leads us to artificial incubation, which Lauren mentioned with the hatchery, and we were grateful to partner with the hatchery. But this artificial incubation, it's used to increase hatching success. And nests are excavated, eggs are collected, as Lauren showed us, and they are incubated under consistent temperature and moisture conditions, which differs from our natural nest sites. And this can influence hatchling size and sex, with many of our turtle species having temperature-dependent sex determination. And what we wanted to see was, does the incubation environment affect post-hatching success and movement? And so we have 3 sub-research questions. Does incubation type influence post-release hatchling survival, movement patterns, and habitat selection? And so this is our study site, and we were really grateful to have Long Point Eco Adventures supporting us. And just then to the south is Turkey Point Marsh. And as Carrie spoke a little bit about the interception fencing just along Front Road at Eco Adventures, and this nest mound, it provides suitable substrate for snapping turtles to nest, and also helps mitigate road mortality as turtles come up from Turkey Point Marsh. And although the mamas can get up there, we wanted to know, can the hatchlings make it back to the marsh? And so there's this ravine and forest, and it's quite steep. Josh, my field partner, we had traveled down the ravine quite a few times, as did Lauren and Matilda. And it's hard for humans, so little tiny turtles. Well, I'll show you what we did. So we conducted nesting surveys, and also thank you to Wildlife Road Watch volunteers. We had 4 clutches from natural nest sites, and we excavated the nests, we weighed and measured the eggs, and we also looked at nest chamber depth and the moisture and temperature of the nests. We had a split clutch design where, here's a mama turtle after she finished nesting, and just over half of the eggs, depending on clutch size, would be returned to the natural nest, and the other half would go to be artificially incubated at the hatchery, and this was to control for maternal effects. And fast forward to them hatching, we outfitted 40 hatchlings with radio transmitter tags so that we could track them. And there were 5 hatchlings from each of the 4 clutches. 20 of them were naturally incubated, 20 artificially, and then we released them all at the natural nest site after they were tagged. And we then tracked hatchlings for up to 30 days post-release, and we characterized the habitat features, microhabitat, macrohabitat, the weather conditions, and also hatchling behavior. And so we just finished tracking at the beginning of October, and in just under 2 months we collected over 600 tracking points, and really grateful for everyone's support in that. And Out of 40 hatchlings, we had 16 confirmed survivals, and you can see that the artificially incubated hatchlings, there were more of them that did reach the end of the 30-day period. And then confirmed mortalities, we did have 4. We also had 18 suspected mortalities where we only found the tag, and we assumed that could likely be due to predation. And there were also 2 hatchlings where their fate were unknown. But here, I'll show you the movements of the hatchlings, where the circles are the artificially incubated hatchlings, and the squares will be our naturally incubated hatchlings who emerged from the nest. And just to situate us, the boardwalk is just to the south. It's a beautiful boardwalk that overlooks Turkey Point Marsh, and then the ravine stream. So there are some of the artificially incubated hatchlings popping up and starting to move. And then the squares are the naturally incubated hatchlings. You can really see them starting to spread out. So this is what our map looked like at the end of the 2 months. Lots of little hatchling points. And so did the hatchlings make it to the marsh? There were 3 who made it to a marshy area, and these were all naturally incubated hatchlings. None of the artificially incubated hatchlings did make it to the marsh in the 30-day period. But we did have hatchlings make it to water in the ravine stream, and 7 of these were artificially incubated, so you can kind of see that movement pattern along the ravine. Hatchling movement, the furthest total distance traveled was 432 meters, which you might be able to see up there. One of our hatchlings had quite the journey. And then average daily distance traveled, there's quite the big standard deviation. They would often stay in one place for a couple days and then make larger movements. But just to compare and look at the space use, we have a minimum convex polygon to just around the outermost locations, and just you can really see how the naturally incubated hatchlings, they went out there. And shout out to Burning Kiln Winery, where we found one of our hatchlings here. And this hatchling crossed the road and made it all the way up into the vineyard, which was quite a surprise to us. But the hatchlings take us to wonderful places. And so the most commonly observed behaviors was not going to the vineyard. It was hiding under cover, burying in substrates. So we'd find them under moss or grass, and then also once they did reach water, they would really kind of bury into the mud, and they would tend to stay there. And so we just finished fieldwork a month ago, and we have more to come. And to end the presentation, I just wanted to share a few of our turtle journeys. So this was our first hatchling that we released from the first clutch, and we started off at the nest site. And this hatchling didn't move for around 3 days, and then there was rain, and the hatchling did move all the way into the forest. And we went into this kind of drainage culvert, and we found the hatchling hiding under a little rock. And we then went to another culvert where you can see the hatchling. Well, yes, it's huge here, but just outside, so that it had likely traveled through multiple different culverts. And one of our hatchlings, we didn't get a signal for a couple days, and we were a bit concerned that predation maybe, and this was towards the beginning of our study. And we then found the hatchling in the ravine stream in the water, And that was a very happy moment. So here is another hatchling. This was a naturally incubated hatchling from the last clutch. And this hatchling moved just under 100 meters overnight and traveled along the fence, along the eco fence, and went to the west. So this was a different movement pattern. But we found the hatchling just at a point overlooking the marsh. And then here is one of our other hatchlings, or one of the other hatchlings that were naturally incubated, and they made it past the boardwalk, and they were getting real close to the marsh. This is at the end of the 30-day period, so hopefully they made it to where Lauren Nightingale, we would go to release the hatchlings. And yeah. And this is one of the last hatchling that I'll show. This is hatchling 25, one of the naturally incubated hatchlings and the only naturally incubated hatchling to go to the ravine. And I remember when Matilda and we were out tracking, and we were wondering, where is the hatchling? The signal is bouncing everywhere. Maybe it's just the ravine. But the hatchling was in fact moving. Quite the journey for a very little hatchling. And yeah, well, I'll end there. But thank you so much, everybody. And I just want to say thank you to all of our supporters, research partners, and those who funded our project. Thank you to everyone who supported us in the field. And thank you to the turtles.
Who is a second-year PhD student at Western University, who is co-supervised by Dr. Jed Long at Western University and Dr. Tyler Wielden at the Ontario Ministry of Natural Resources and Forestry, as well as Trent University. Her research uses GPS technology to investigate drivers of coyote movement and predator-prey dynamics within the Long Point National Wildlife Area. All right, so here we go.
Hi, everyone. My name's Kiana. I'm a PhD student from Western University, and today I'll just be presenting on my thesis project, which is exploring the ecological role of coyotes around the Long Point National Wildlife Area. So before I dive into my research, I just wanted to give a quick overview of where my research is taking place. So as the title of my presentation suggests, my research occurs around the Long Point National Wildlife Area. As many of you know, Long Point is one of the most ecologically important sites in southern Ontario, supporting a wide diversity of wildlife species, including migratory birds, reptiles, amphibians, and mammals like deer, and of course, coyotes. So what makes the study area really special is that there's very little human activity within the National Wildlife Area, which gives us a unique opportunity to observe how animals move, interact, and behave in a relatively natural ecosystem. So as many of you probably know, there's a lot of ecological challenges associated with white-tailed deer in Long Point. In the past, overabundant deer populations have led to overbrowsing in some areas, which has significantly altered the vegetative community around Long Point. And this has led to habitat degradation, and as a result, negatively impacts wildlife communities, including migratory bird populations that depend on intact vegetation as habitat. So in response to the overbrowsing by deer, Long Point has implemented lethal deer management efforts to reduce deer populations to low enough densities to restore ecological balance. Within Long Point, coyotes are considered the top predator, which raises the question of how effective are coyotes in naturally regulating the deer populations, and if so, can coyotes help manage deer populations naturally? So that brings us to our research project. At a broad level, our project is interested in understanding the ecological role of coyotes down at Long Point. Specifically, we want to know how coyotes move through and use the landscape, how their presence might influence deer and other prey species, and what that tells us about their role in maintaining ecological balance down at Long Point. So in order to explore these questions, we're using a few different tools such as GPS collars, camera traps, as well as eventually diet analysis. But for today's talks, we'll be focusing more on the GPS telemetry side of the project. So I'll be walking you through how we've been capturing and collaring coyotes, and just sharing some general and interesting movement patterns and findings that we've documented so far. So in order to study coyote movements, the first thing we need to do is we need to safely capture and collar coyotes. So we use humane capture methods approved under animal care guidelines, and these are designed to help minimize stress to the animal and also helps ensure both ours and the animal's safety. So in order to capture coyotes, we use these traps called padded foothold traps. I don't have a great picture of what the trap looks like, but here's a picture on the left of my supervisor holding one. It's a little bit hard to see, but underneath my supervisor's thumb, there's a circular trigger, and that's called the pan, and that triggers the trap to close around the coyote's foot once it steps on that pan. So when we decide where we want to place our traps, we try and place it around the right type of vegetation around the shoreline of Long Point. We look for vegetation that's big and wide enough to guide the coyote's path so that it forces the coyote to approach that trap in a certain direction. So once we've decided where exactly that right spot is, we place that trap in front of that vegetation, we bury it, and then add a really smelly bait or lure that draws that coyote to that area. So here's a few photos on the right of what the general trap setup looks like. But once that trap is all set up, this is what a complete trap set looks like once it's ready to go. Usually we'll try and set a maximum of 30 traps at a time, sometimes a little bit fewer. If a trap doesn't show that much sign of coyote activity throughout our trapping stint, sometimes we'll dig it up and move it to another location. So that's why on November we'll have like more than 30 traps at a time. So over here, this is just a map of our general trap line during fall during the last 2 trapping stints, with the dots representing the locations of where we placed all those traps. As you can see, most of our traps are located along the shoreline of the wildlife area rather than in the interior of Long Points. And there's a couple reasons for that. First, we often see fresh coyote tracks along the beach from the night before, which tells us that there's a lot of coyote activity within that area. Coyotes usually travel the shoreline, so concentrating our trapping efforts there increases our chance of successfully catching a coyote. Second, working along the beach allows us to check traps more quickly and efficiently using ATVs. So that means we can cover the full trap line quickly and minimize the amount of time that a coyote might spend in that trap, which is important for animal welfare and safety. So we'll check our trap line every morning after sunrise, as well as sometimes in the late afternoon before sunset. So when we do our trap checks in the morning, we hope that there's a coyote there. However, even with all the effort and the number of traps that we set out at a time, catching coyotes can just be really hard. Coyotes are really smart, they're super cautious, and sometimes super suspicious, which makes it really difficult for us to catch them. So here's a few examples of what it might look like when we check the traps in the morning and what we might call near misses. So here's the locations of the traps, as well as the locations of the coyote footprints. In the photo on the left, we can see that there's a couple of coyotes that look like they were interested in the trap and that looked like they were going to approach it, but for some reason turned around and decided to go the other way. In the photo on the right, I'm not exactly sure what happened here. There's a lot of paw prints around where that trap was, and it seemed like they were generally interested in that area. But sometimes it's just a game of inches, and even if that coyote's foot is like half an inch from where that pan is, that trap won't trigger, and that coyote will walk away uncaught instead. But other times, we're really lucky and a coyote is there in the morning. So when we arrive at that trap, the coyote's paw is secure in that trap, so it can't really move. But before we actually process and put that collar on the coyote, we need to safely restrain the animal to protect both it and ourselves. And we do this using a catch pole, which is basically just a noose that keeps the coyote within a safe distance away from us and prevents it from biting or scratching us. Once that coyote is safely restrained, we then go behind it and chemically sedate it to make it really sleepy. And this just helps reduce the stress and ensures that we can handle it both safely and calmly. So once that sedation does take effect, we'll move that coyote and take it out of the trap and move it to a shaded and quiet area where we can begin to safely process it. So once that coyote is sedated, we take the basic physical measurements such as weight and body length. We'll also examine the teeth to estimate the age of the coyote. And then we'll also collect hair and blood samples for later genetic and health analysis. Most importantly, though, is we put the GPS collar on the coyote, which records the animal's location and allows us to track where it goes once we release it. So once that coyote has been processed, we'll move them away from the shoreline and administer a reverser, which basically just reverses the effect of sedation. The coyote will usually wake within a few minutes and then run away. So here's a video of a coyote waking up after we've administered the reverser and then we've backed away safely. Usually they're a little bit wobbly when they first wake up, but then they quickly regain their footing and head back into the interior dunes or the interior of Long Point. So the overall process from when we initially sedate that coyote to release it usually takes about 30 to 40 minutes. And throughout that 30 and 40 minute period, we extensively monitor that coyote to make sure there's nothing bad that happens to it. So once we put that GPS collar on that GPS collar is now live, and that coyote will start sending locations to us. Our collars are connected through the Iridium satellite network. You can think of that Iridium satellite network as a global network of satellites orbiting the Earth. Each collar sends its information up to the nearest satellite overhead, and then that satellite relays that data to a ground station, which forwards it to us over the internet so we can access the location of the data through our computers. And then because the Iridium satellites circle the entire globe, we can receive data even from remote areas with no cellular service, which is especially handy in our case since within the interior of Long Point, there's 0 cellular coverage. So we've reprogrammed our collars to send a GPS location every 3 hours. However, we've included specific high-resolution sampling periods that we call our high fix weeks, where the collar collects data every 15 minutes. So we have 3 high fix weeks throughout the year, 1 in November, 1 in February, and then 1 in late May, which helps give us a more detailed picture of fine-scale behavior and movement. So far we captured a total of 24 coyotes and have deployed 19 GPS collars on them. So what you're looking at in this map over here is a map of all the GPS locations we've recorded from our collared coyotes since the beginning of the project in 2023. If you look at the map on the bottom, you can see that some individuals, the ones that we like to call our residential coyotes, stick around the Long Point area and establish clear territories within the National Wildlife Area. Other coyotes, which are known as transient coyotes, don't really establish a home range and have a more widespread movement around the Lake Erie landscape. So if you can see the smaller map on the upper left, you can just see how far some of them have traveled. We've documented coyotes going from Long Point all the way to Point Pelee, to Windsor, and even James and Allen Provincial Park. We've also recorded one particular coyote crossing Lake Erie during the winter of this year, and I'll get to that story more on the next slide. So last fall, we captured an adult male, which I named Buford. Buford made some very interesting movements, which we were lucky enough to be able to document. So here's a short video showing his movement paths. But shortly after we collared Buford, he decided Long Point wasn't really for him, and he soon left the peninsula and started heading southwest along the shore of Lake Erie. Over the next months, he traveled roughly 200 kilometers, eventually reaching Point Pelee right around Christmas. He stayed in the provincial park for a short while before turning back and making his way to Long Point again, which we were really excited about because we thought we would be able to collect local data at our study site again. But once he got back to Long Point in January, it was during a deep winter cold spell. The lake started to freeze, so instead of staying at Long Point, he decided to keep going east right out onto the lake. So Buford's an interesting coyote since he's one of the first actual documented evidence of the coyote using Lake Erie to cross from Canada to the US. Unfortunately, though, we don't have a final GPS point confirming whether he made it safely across to the US, as the collar stopped working right before he hit that US shoreline. So we could chalk it up to a government conspiracy, but it probably likely had to do more with the ice coverage and thickness around the time Buford had crossed. So in this video over here, you can see his movement paths overlaid with satellite imagery of ice coverage from the dates of when he crossed Lake Erie. So the last GPS point corresponds to an area with very low ice coverage, so it's hard to say what exactly happened and why he didn't make it over. So while some coyotes like Buford travel really incredible distances, most of the individuals we track actually stay within the Long Point area and form stable and clear spatial boundaries. So based on the GPS data of the collared individuals, we've decided that there are some dominant breeding pairs that we have collared, as well as their offspring. So we have the western pack, and we've called it the dominant breeding female, as well as her 3 offspring. In the central pack, we have the dominant breeding male. We think we've collared the dominant breeding female, but we just recently collared her, so it's too early to say if we know if she's the dominant breeding female. And then just 2 of their offspring. And then we have the eastern pack, and then we have our dominant breeding female there, as well as her 2 offspring. So when we plot the GPS locations of the dominant breeding pairs and their offspring and delineate their home ranges, we can see that these packs partition space, how these packs partition space across the landscape. So as you can see in this map below, each pack occupies a distinct area, forming the western, central, and eastern territories with very little overlap between them. And these boundaries are remarkably consistent over time, suggesting that these packs maintain stable, long-term territories within the National Wildlife Area. So overall, what we're starting to see here is a really interesting picture of how coyotes at Long Point are organizing themselves spatially and how they form distinct family groups that maintain well-defined territories. So now that we've identified these territories, the next step is to start linking these spatial structures to the ecological questions driving our research, which is how are these packs interacting with each other, how do these packs differ in how they might use habitat, and what these ecological patterns might mean for deer populations and prey dynamics. So in order to start answering these questions, one of the things we can do is quantify social interactions and see how individuals or packs encounter one another and how those interactions occur spatially across Long Point. Because coyotes are often hunt deer more efficiently when working together, understanding how these social dynamics occur across space will help us infer how group behavior could influence deer predation or scavenging success. Also, because habitat is very diverse across the Long Point area, we can also link these territorial boundaries to habitat features to see how habitat selection or resource use differs among the western, central, and eastern packs, as each territory is dominated by slightly different habitat types. And then finally, since we have a complementary camera trap study and we're also collecting diet data through scat analysis, we'll be able to start exploring how space use connects to prey use and how deer interactions and prey consumption might vary between coyote packs and territories. So that's about it for my presentation. I'd just like to end it by thanking our partners at CWS, Danny Bernard and Sam Milan, and the wonderful co-op students who have helped with all this data collection. I'd also like to thank my supervisors, Jed Long and Tyler Wielden, and everyone in the Geospatial Analysis Lab, including Lauren Stoner, for all their help and support with this project. And then that's it. I don't think there's time for no questions. Yeah.